You got one part of that wrong. This is not meth.
Walter White is actually right. That isn't meth. It's mercury fulminate. And while we're not going to be synthesizing a 50-gram crystal like he did, I say, let's make it. Hello everyone, my name is Cam, and we are going to be doing some chemistry. Today, we're going to be synthesizing some mercury fulminate. Mercury fulminate is a primary explosive. It detonates at around 4,200 meters per second. It was mainly used as a primer until the end of World War II, when countries started switching to safer and less toxic alternatives. A warning. This video is only for scientific purposes. I am not condoning the synthesis of mercury fulminate. Rather, I am showing you all how dangerous it is and why you shouldn't make it yourself. Also, it is never okay to synthesize a compound with intent to use it against anyone or anything, especially energetic compounds like mercury fulminate. It should be noted that the synthesis of mercury fulminate is extremely dangerous as it utilizes highly toxic mercury metal and highly corrosive nitric acid. Also, mercury fulminate is extremely sensitive to shock, friction, and heat, and has been known to spontaneously detonate. Now onto the synthesis. First, 10 milliliters of concentrated nitric acid was added to a beaker. Then, 1 gram of mercury metal was added to the solution. The mercury was allowed to fully dissolve in the nitric acid before proceeding to the next step. What's happening here is mercury reacts with the nitric acid, creating mercury nitrate. The reaction also generates heat, water, and lots of nitrogen dioxide gas, which is toxic, flammable, and corrosive. Once fully dissolved, the solution should be somewhat greenish yellow. If the mercury isn't fully dissolving, slightly warm the beaker to help the reaction. Next, gently warm 20 milliliters of absolute ethanol. I found that the denaturants in denatured ethanol do not let the reaction occur, so I recommend using undenatured alcohol. Ethanol is extremely flammable, so do not warm it above an open flame, like a stove. Once the ethanol is around 35 Celsius, add it to a round bottom flask. To the round bottom flask, add your mercury nitrate solution. The reaction may not start at first like mine, so gently warm the flask with a hot water bath. Be very vigilant and remove the flask from the hot water bath once the reaction begins, to avoid a runaway reaction. Once the reaction begins, white gases are produced, which are toxic and flammable. The reaction is self-sustaining and will continue until no white gases are produced. Once the reaction finishes, a brown grayish precipitate should be at the bottom of the flask. This is your crude mercury fulminate. Make sure you wash it with water and finally ethanol to remove some of the impurities. There is an optional step to recrystallize, but I do not have glacial acetic acid, so I will not be taking that step. I will link the directions of recrystallization in the description. My yield in this synthesis was about 1 gram, which isn't that great, but I was very hasty with my decanting, so I probably lost a lot of the product there. Compare your yield with mine in the comments below to see how you did. Mercury fulminate can deflagrate quite easily when exposed to a flame source. When confined, the deflagration can transition to a detonation, which is dangerous. The decomposition products of mercury fulminate are carbon oxides, nitrogen oxides, mercury vapor, and atomized mercury, which you can see is the black stain on the stone. As you can see here, it is also very sensitive to shock and friction. If you'd like to store your mercury fulminate, I highly recommend storing it under water and recrystallizing it, as it reduces the compound's sensitivity to friction and shock, as well as improve its long-term storageability. Thank you for watching my full synthesis of mercury fulminate. Please give the video a like, as I put lots of research and time into it, and subscribe to the channel for future chemistry tutorials. If you have any lingering questions, I'm happy to answer them in the comment section.